Hi, it's Mrs. Pope, and today we're going to talk about log equations and inequalities. Our goal is to use the property of logs to solve log equations and inequalities, so we're going to learn a few properties here today. First, we are going to solve log base 36 of x equals 32, and we already know how to do this just by using the definition of logs. So, the only thing different is I have an exponent that'll be rational, so we're going to have to remember back to rational exponents. So if I were to rewrite this, this gets rewritten as 36 to the power of 3/2 equals x. So now we have a rational exponent, and remember, the denominator becomes the index, so this is the square root of 36 cubed. So of course the square root of 36 is just 6. 6 cubed is 216. So x is equal to 216. I'll just do another one just so you can see it again. Log base 9 of x equals 3/2. That turns into 9 to the 3/2 is equal to x because of the base to the power of the big number. Base to the power of the answer is equal to the big number. So again, this is the square root of 9. Square root of 9 cubed, which square root of 9 is 3 cubed, which would be 27. All right, here comes some new properties. Key concept, property of equality for log functions. These are very important when we're solving because we use these all the time. So the symbols say if b is positive but not 1, then log base b of x is equal to log base b of y if and only if x is equal to y. So what that means is if you have two logs with the same base, you can set whatever it is you're taking the log of equal to each other. I showed a simple example here. If log base 5 of x equals log base 5 of 8, then x is equal to 8 because these two things can be set equal to each other. All right, let's look at an example. Solve log base 2 of x squared minus 4 is equal to log base 2 of 3x. So the key here is that log base 2, log base 2. If you have the same bases, then you can set the x and the y equal to each other. So I can set x squared minus 4 equal to 3x. By doing that, I can go ahead and solve it. It'll just be a quadratic. So what I would do here is subtract, get everything on one side, set it equal to 0. So I would subtract 3x from both sides. So you'd have x squared minus 3x minus 4 equals 0. And you can use whatever method you prefer to solve quadratics. I always try to factor first because usually that's the easiest. So we see if this can be factored. What multiplies to negative 4 and adds to negative 3? Yes, it can. X minus 4, x plus 1 is equal to 0. So my two answers would be x equals 4, because that would make this parenthesis 0, or x equals negative 1, because that would make this parenthesis equal to 0. The only thing here now I have to do is check. You must check your work on each one of these because sometimes they will not work when you put it into the original equation. So let's check 4. Log base 2 of 4 squared minus 4 is equal to log, we're trying to see if it's equal to log base 2 of 3 times 4. Right? So log base 2 of 16 minus 4 is 12. Does that equal log base 2 of 3 times 4? Yes, it does. So that one works. Let's try the other one. Log base 2 of, negative 1 squared minus 4. Is that equal to log base 2 of 3 times negative 1? Well, let's see what happens. Log base 2, negative 1 squared is 1. 1 minus 3 is negative 3. Is that equal to log base 2 of negative 3? Yes, they are equal, but you cannot have an answer. You cannot take the log of a negative number. You can't take log base 2 of negative anything. So this is where the problem is. Yes, they are equal, but this is not a solution because you cannot have a negative in this place where x and y are. So your answer, your final answer would just be x is equal to 4. So if you write both of them down, it would not be right because I know you didn't check it. If you would have checked it, you would have saw that you came out with a negative here. All right. properties of inequalities for logs. So, key concept, if b is greater than 1, x is greater than 0, and log base b of x is less than y, then we can simply set it up, x is, or I said less than, greater than y, x is greater than b to the y. So that doesn't change, it's just b to the y, and we have the x, just the symbol is different. If b, same thing here, but if we change this to less than, then it changes. X is between 0 and b to the y. So let's see how both of these work quickly. Solve log base 3 of x is greater than 4, so let's see which one we're using. B is greater than 1, yep, it's not, it's greater than 0. And log base of x is greater than y. Okay, so now we can use this. X is greater than b to the power of y. X is greater than 81. So you can stop there. That's literally all you have to do. The next one, log base 2 of x is less than 4. So I can see that I have less than. So that means my x, whatever it is, must be between 0 and b to the y. So x is between 0 and b to the y, 2 to the 4th. So x is between 0 and 16. So this would be my answer here. This would be my answer here. That's all there is to inequalities. Thanks for watching, and remember, you are responsible for your own learning.